Hey, good morning, everyone. Good morning, Brandon.
Morning, Kurt.
Hey, welcome everyone to the third Perspectives on Global 3D Sand Printing, featuring a couple of interesting folks here from the casting industry in North America. I'm Kirk Rogers from the Barnes Global Advisors. I'm an advisor and our technical excellence leader. I'll be hanging out at the TBGA table. If you have any problems, come find me there or ping me in the chat and we'll help get you squared away. With that, I'll say, Brandon, take it away.
All right, thanks, Kurt. Good to be back. Hard to believe another month has gone by. We're
No kidding.
Patty's Day. Happy St. Patrick's Day to everyone. Thanks for spending some time with us. I'm going to have Rich and Jerry join me here. We're going to get their mic and their cameras on, and we're going to start into the presentation. As a kind of leading into this is kind of where it all started. Myself and we went to the America Makes in Youngstown, Ohio, and said, we really are interested in this 3D printing technology about 7 years ago. And, we said we wanted to learn more. We wanted to understand it. We saw value, but we didn't really know how to access it. There was very, very few machines at that time. I think Ford Motor Company was one of the only ones that had machines in the United States. And then, lo and behold, an America Make project came about where they plugged us in with Jerry Thiel. And they said, hey, hop in it. He said, yeah, come on out anytime. So I hopped in my truck and I drove, 10 hours or 700 miles door to door and, got to meet Jerry. I hadn't really met him. But, it was he was very receptive, opened up, open arms, welcomed us in and said, hey, we want to learn about this technology together. We want to push it out to the industry. And, so we were very, very excited and, spent a lot of time out at University of Northern Iowa. They were very gracious, gave me some office space and would drive 50,000 miles a year. Rich Lonardo would hop in the truck with me as the principal investigator of the America Makes project, keeping us online and helping make sure that we were to accomplish the mission at hand. We did a really good job of that with a lot of partners. It wasn't just us three, but this was kind of the core group. So, Jerry, if you can get your camera and your mic on. We're going to wait for you, and then I'm going to share the screen here, and we're going to hop into the presentation. But thanks so much, guys, for joining me this morning. And without further ado, I'm going to share my screen, and Jerry, you can hop right in on the presentation. All right, can everybody see the screen?
I can hear.
All right, sounds good, Jerry. Take it away.
Well, next slide. Okay. Back to the first slide. You'll see on the left-hand side the Modern Castings top tank. That was actually runner-up at one of the cast expos for the casting of the year. And on the right side, you can see those cores being produced. We had, and Brandon was around when we first started producing these. This was early in 2014. We've been doing this. We bought our printer in 2013. We sent X1 a PO and had the printer shipped over on a 747. We had the printer on U.S. soil within 1 week. And installed on the third floor of the building within a month. So very interesting start to what we wanted to do. And next slide is advance the metal casting industry with this really fantastic new technology. A little bit about the Metal Casting Center, if you're not familiar with us. We've been in existence over 30 years. We're one of the longest operating centers of excellence for metal castings at a university in the world. We do product testing services for the Foundries material supply chain, applied research and technology for the foundry industry, program support for the university's academic program. In fact, over the last 7 years, we've spent over $2 million on student salaries alone. These students have an opportunity to work up to 4 years part-time at the metal casting and additive manufacturing centers, and very highly recruited and sought after by the industry. They have those skill sets for a company to be able to adopt manufacturing 4.0 technologies. And that's our major benefit to the industry. And then also direct support to the operating foundry industry on solving some issues in the materials, processing of metal castings. Next slide. So what did we do? We took our experience in industrial research, foundry materials and processes. We knew how to stick sand together very, very well, and we applied it to additive manufacturing. We're very highly involved in the industry associations, the American Foundry Society, Steel Foundry Society of America, Non-Ferrous Foundry Society, and also the Investment Casting Institute. Demonstration projects are our specialty. We focus on OEMs, and this is important to understand. We focus on OEMs because they're the purchasing in the supply chain. For them to understand the potential of new technologies, once they understand and they start looking at parts being produced, then we move down to the small to medium size supply chain for castings to be able to provide information and support to adopt and utilize. Defense projects, we have defense projects with the Army, the Navy, the Air Force, and through the Defense Logistic Agency and national labs. Next slide. So we were the first university to purchase a large industrial sand printer. And everyone asked me, why did you buy this thing? And the answer was pretty short. If a company takes a risk to buy a piece of equipment that's $1.5 million and it fails, then it's a big deal. We can fail. We can make those mistakes up front. Also with developing materials, low cost and regionally available materials for the industry. So let the universities take the risk and the research and development, let the industry take the advantages and the benefits from that research. We've developed over a dozen aggregates for 3D sand printing. We were told that this is impossible, you can't do this, we need special sand. We showed the industry, we showed the OEMs that using different setups and using care, that just about any commercial molding aggregate can be used for 3D sand printing. And the university still prints more materials than really any sand printer in the world, including X1. We developed domestic furan resins and various catalysts and formulations. We developed the first iron oxide feeder for steel castings or heavy iron castings to prevent veining and in cores produced by a 3D sand printer. And we're currently helping equipment suppliers develop the next generation sand printer. For those of you who are fairly new to the sand printing industry, the work we did at UNI reduced the cost of printing materials, that's resins and sands, over 80% from the original materials offered by the printing companies. Next slide. So we talk about helping companies, one, develop the products for 3D sand printing, or develop the technology. What you see here is what we call the alpha printer. We'll talk a little bit about the beta printer, which is a little bigger one. This one is a printer used for research and development of those resin systems. Furan, phenolics, inorganic binders, and more recently, urethane type binders for additive manufacturing, which have much more compatibility than the furan resins that are the majority use today. Industrial research, development of multiple domestic 3D printing aggregates. We look at working with new companies, both in the natural mineral deposits, whether that is silica, whether that is chromite or zircon, or the man-made aggregates such as the ceramics, the mulites, and also our industry associations, our staffs. And how do we get this information out to people? Our staff serves on over 8 technical committees through the technical organizations. So we are out in Foundries, talking to people, transferring this knowledge. Next slide. Also, I'll put a little plug in for investment casting. As a lot of research and development centers for the foundry industry, we're working into manufacturing 4.0. And we're looking at fully operated, fully automated units that take the requirement of the manual labor out of the production process. And this does 2 things. It has a great effect to control costs of producing products, but it also removes the human error. So we can do things the same way every time. Low-cost sensors, you'll see us publishing information on sensors that give us temperature, moisture, gas chemistry, pressure, shift, or impact. We can either install these sensors for Internet of Things information on equipment or place these inside of molds or cores to give us the exact conditions so we can make better decisions. All of this Internet of Things and sensors is to provide information to the foundrymen to make those good decisions, but also to understand what's happening now, not in a week or so when the castings end up in the cleaning room. Robotics and automation in casting finishing, and also next-gen sand printing. Next slide. So what I want to talk about is what's happening now in research and development in 3D sand printing. And I'll go to domestic quality. So domestic quality for a North American OEM, and in this case, it's Tinker Omega, Springfield, Illinois. This is our beta printer. It's been a long time coming. I get ribbed by a lot of people in the industry. Hey, you got that printer yet? It is a long time coming because the technology advancements that will be made in this equipment are substantial. Increased speed, and we're talking about printing molds and cores the day you need them. Not for tomorrow, not for the day after. More choices, and the system won't be tied to a specific resin system. So it'd be available to run these new systems that we're working on right now. Greater flexibility to vary resin percentages within the same job box to give you a selection of core strengths, one for easy shakeout and one for small, lacy, delicate cores. And also the next generation of software with increased capabilities. All this takes time. We're hoping to receive the printer within the next 30 days. Next slide. So moving into what are we working on again? Manufacturing 4.0 technologies, which have been proven to really advance the foundry industry and suppliers of castings. If there's one thing, and we talked about this before the presentation started, it's the companies that are spending capital and making capital improvements in automation and technology that are viable for the future. The castings that have refused to adopt or did not have the capital to modernize and automate their companies are really sadly falling behind in closing at a very disturbing rate. We call these manufacturing 4.0 technologies, and additive manufacturing is a big part of that. Not just in sand printing, but also in printing tooling, printing patterns for investment casting. Additive manufacturing is making the time between design conception and realization of that casting incredibly short, where we can have complicated castings within 24 hours. Automation, removing the manual labor, advanced manufacturing processes, process sensors, and the Internet of Things. We're pushing the limits of current technology in sand printing, also to reduce respirable silica, and also to utilize sands that we would have never used in the past. Cost, availability, and time to market. Also, one of the things we're working on is stronger heat-resistant cores. If you've used phenolic, either phenolic or furan cores, you know that there's limitations in the size of that core, in the laciness, and the ability to be able to pour higher temperature alloys such as steel for dies, or even those pencil cores for light metals, aerospace castings. We are working on technology that improves the strength of those printed cores by 4 times. And usually we're looking at about 250 to 300 transverse strength on a printed sand core. And we've run cores over 1,000 PSI. That, coincidentally, also shake out very easily when cast. Next slide, please. So what are we developing technologies for? Hybrid molding, better performance in resin systems, better surface finish through coatings, faster and more flexible printers, better software, process sensors, and increased use of non-silica sands. In this, I wanted to throw this in the end because everybody thinks that all this is very, very simple and easy. Down in the left-hand corner, you'll see cores for these were some of the first printed cores for aerospace castings. This was for a prototype engine, not flight ready, but on the test stand for SpaceX. They're rocket engines. And on the bottom right, you see the result of some of our testing and some of our pushing the technology as far as it will go. And I'll conclude after that.
Thanks, Jerry. We're going to run right into Rich and his DoD perspective, and then we'll open up for a Q&A at the end. Thank you so much.
Thanks, Jerry and Brandon, for the intros, and Jerry for all what you and I has done with workforce development and Tech D. Greatly appreciate it. My pitch today for the audience is the focus is to stimulate conversation at the tables about how we sell the advancement in terms of utilization of additive manufacturing for tooling to the ultimate customers who benefit from what all of you do. And so I hope to pull that thread out and give you my limited perspective. And of course, I'm just a consultant, so I'm not speaking officially for DoD, but this is the things that I've seen lately. So I have 3 slides. We'll get through them real quick, and hopefully there will be a lot of chat. Brandon, next slide, please. So I guess I wanted to approach this from a simple SWOT analysis and pick all of your brains on how we communicate our value proposition for tooling. And I need to learn from all of you because every day I learn more from folks like Jerry and Brandon and Kirk and Cynthia and all of you who are actually out there making things happen. And it's interesting that Ford Motor Company, and maybe we have the guy who made it all happen at Ford on today, and who responded to an invitation on LinkedIn for me and helped guide me on how to do an America Makes project. Or maybe we have somebody out of Keyport who also had an S15, in the 90s and had the early arrival of X1 technologies to do in-house stuff for DoD. Now we have Rock Island Army Arsenal with an X1 asset. We have Tinker Air Force Base and the React team with X1 asset. And so The organic capabilities in DoD means that the DoD enterprise, including the R&D organizations, know the opportunities that binder jetting can provide in terms of schedule and also complexity and moving towards production of parts and addressing what we all know. Castings and forgings are always long lead time in the eyes of DoD, right? Significant investment that I see, I'm consulting on a project for the Air Force under AFWorks, and they're going really fast using pitch decks by which small companies like mine can go to a university powerhouse like Jerry and say, hey, Jerry, I want to do a small business innovative research or small business technology transfer around a widget and the technology, and I want to use AM. And DoD is funding a lot of research around additive, but also, as Jerry mentioned, around advanced manufacturing, which involves robotics and sensors and IoT. And as we all know, and those of you who are out there doing global work, Europe and Asia are making a lot of investment from their governments as well. So that's the opportunity before us. There's investments going on, awareness of the tech investments in the areas that impact us. I think the challenge, and this is where I need to hear from you guys at the chat table, is how the heck do you explain tooling to your grandma, your spouse, or an ultimate client who says, what do you do? And you say, oh, we use additive manufacturing, we're a foundry, or we're using high-speed technology so that we get a part to you faster. And I think that's the challenge I need to learn from you guys. How do we communicate the value proposition of what great universities like University of Northern Iowa is doing, or Hometown Products, who makes the investment in this, when ultimately the customer or whoever uses that part may not get to see the speed, the market advantage. And I'll use, if I'm a commander, warfighting sync, and I have to put platforms against the task, you know, is that plane, tank, ship, or underwater platform more available to me because of all of you guys here at this presentation today? And if it isn't, not because of your fault, but because of the bureaucratic defense procurement process, I don't see the value proposition that you give me. And I think that's what I need to learn from you guys, is how do we communicate the value of AM for tooling out there when all I hear from 4-stars is we want to be the first service that uses a printed part on an aircraft, right? And then I try to change that conversation into, how about you increase operation availability of that aircraft, or the cost for maintenance repair operations because of additive manufacturing? So we try to change the dialogue, but again, I need to learn from you guys on how tooling and its benefits are advantages to the ultimate end user. Let's say 5 years from now, our kids are driving cars that are hybrid electric, or we are, maybe a Lordstown Motors pickup truck, and the body panels are lighter because of the benefits of additive manufacturing for tooling. And how do we put ourselves in that success change? Next slide, please. So those are some initial observations that I wanted to throw out to you. And on the next slide that Brandon will put up here, we'll talk about a couple other things. So I'm changing SWOT from opportunities and threats in terms of order. The big thing I notice is there's more and more investment and discussion on direct printing of parts. And all of the DoD forums and the National Defense Industrial Association Manufacturing Division meetings, more and more investment goes from tooling to say, we want to directly print the part because that's the way we skip process steps, we save time, and we save money. And I don't necessarily agree with that logic, but that's what happened. Last week or the week before, I saw 2 briefs on direct energy deposition technology funding from DoD to small businesses for casting repair. So it's this old thing, casting versus weldments discussion, right? And we all know, and we all hope that AM technologies like DED continue to advance, but what does it mean to all of us in the room, right? Is it a threat like I throw out here? I don't know. but I think it's a discussion point, and I think it leads us to opportunities. The other threat I would tell you guys is, and I don't want to mean it as a threat, but it's a challenge in terms of supply chain retention and supply chain recruitment. From my perspective, as a consultant, I try to play around a little bit to be a DLA vendor or throw in R&D projects for my own company as well as others. And there's more and more scrutiny about how we handle the digital thread. How are we handling all the way to you, whether you're an engineering service, whether you're a foundry, whether you're a pattern shop, a print shop, a university, a fellow company, a machine shop. How are we securing the technical data package? And we could all argue about DoD and DLA needs to do more about 2D, the 3D file conversion, right? Roger, got that. But ultimately, what they're putting on us as supply chain members is you have to handle the digital thread securely. And oh, by the way, here's a new requirement. And every week there's a new requirement. It looks simple. Then when you go to find it, you got to go to 3 federal websites and register for this and have a password book that's thicker than the old phone book. So those are some of the challenges. The opportunities here, though, is that we, because of all of you, have gotten our names out here in multiple industries, whether it's the standardization industries, the other transactional authorities, such as America Makes and other organizations, AMC, and we're showing how to get standardized efforts in terms of tech integration, reduce process variability because the great work folks like Jerry's doing. And we have the opportunity, each of us, to educate our clients, and ultimately folks like me try to inform DoD leaders about the value proposition, right? There's all the Beltway folks who are really sharp on how to get us money, but when we get out there, we have to inform them of the tactical successes on how things like binder jetting makes a platform more available against the task, even though they don't know about the value proposition, how it's going through tier 2s, tier 1s, to an OEM who sells it to DoD, and so forth. And so I would say, and get yourself involved. A simple example is the AFS training, I think, is the largest of it, but also have cognizance of these other venues. And if you would like to brief at these venues, let me know, and I'll ping folks like Stephanie Gaffney at YBI or Marilyn Gasca or folks up at OSD, so you can get what you're doing with this technology out to a broader audience, especially those who invest in DoD, and those investments go beyond DoD out to the commercial sector, and hopefully parallel the investments that the OEMs would like to see out of our supply chain so we can work globally. Ending with that, you know, regional manufacturing ecosystems are what we need here to support the defense community in a peer-to-near peer operation. And so if you're doing this globally already, come on down, help create another regional ecosystem throughout the United States that also allows you to compete globally. And maybe we could chat about that as well, and how this technology, along with other technologies that are enabling automation, robotics, and other additive, can all work together to bring our industry up. And how do we effectively communicate our value proposition? So I'm excited and honored to chat here today, but I'm mostly excited about learning from all of you on how we skin this cat, so to speak, and better communicate the value proposition all you bring to the plate. Honored, happy St. Patty's Day from a guy who's all Italian. I'm wearing green. And trying to play nicely. Thank you, and Brandon and Jerry, back over to you guys.
All right, thanks, Rich. You know, everybody here may have heard or maybe, you know, worked with Hometown in the past, but, you know, it was kind of a tall task, you know, for a small company like ours to you know, to see the need. You know, you start all the way up, you know, in the DoD supply chain. You know, we need a casting to get this plane off the ground. It seems simple, but you see what it took for all of us to get this going. You know, we had to reach out through this, you know, this DoD started additive manufacturing center right in Youngstown, Ohio. And then we had to work, you know, with Jerry Thiel, you know, out at UNI with the first printer that a university had in order to get where Hometown is today. So, you know, I brought, you know, like I said earlier, like I said, this is like getting the band back together. You know, I worked closely with these guys for so many years, and I just wanted to kind of get everybody back together. So, because there's a lot of foundries that are in that place right now. Where do we make advancements? Where do we take and where do we, put investments? And, it takes, you have to take that first step and jump out and say, okay, maybe we need to come alongside someone. And a lot of people have come alongside of Hometown. We have a lot of great, customers and clients, and we do consulting, but we're helping our customers crawl, walk, run, where they might print some parts on our printers. And then next thing you know, we're helping them install a printer. Next week, I'll be at one of our clients, installing, an S-Max 3D sand printer and giving training on, how to best utilize that technology in their foundry. And we're honored to do that. And, having the team and the support, with Rich and everything, that's how we're going to get into production. That's how we're going to get into, cores and molds, 30, 40, 50,000 pieces a year, maybe more, as Jerry continues to work on the latest and greatest printers and technology. But, that's where we're really going, as a company. We were honored, to become one of the National Association Manufacturers of the Year, in an industry that's been so, so set for so long. It goes back to, thousands of years of, pouring metal into sand, but to innovate. And, like I said, it's the team and it's all the people, it's our clients, our customers that work with us to get us to that point. So I just wanted to touch, base back with the team. Thank you everyone for joining, and listening here today. Now we're going to open up for some Q&A so we can really deep dive into, what we're doing, as a group collectively to keep advancing this industry. We're not done yet. We're just getting started. So, Jerry, if you guys want to turn your mics and cameras back on, Rich, let's see over. I'm going to pop over to the Q&A, see what kind of questions we have here. Yeah, thanks again, guys. Rich, turn your mic on. We got it ready. All right, great. All right. So one of the first questions we have here is curious on the Tinker Omega printer. Is there any kind of cut sheet for it, or is it too new to have documentation? So Jerry, I'll let you field that one.
I think if you go to the Tinker Omega website, it may be there, but it is too new. So it is too new.
Especially speeds and all that. You're still kind of developing some of that. You might have a close estimate, but you're still developing the finals. Is that fair to say?
Well, we started off this project looking at a 10-time improvement in printing speed. So if we look at even the 28-second per layer time, we're looking at something substantially less.
Sounds good.
The technology is going to allow us to go.
Yeah, there's a lot of interest in that, obviously. The cost of printed molds and cores, started out, much higher than conventionally made cores and molds. So obviously all the work that you've done to drive down the cost of the consumables, has really helped. But we also have to keep working on speed, getting the faster, and then also getting the price point of those down. So, all right, another question here. I had a couple votes on it. Cosel in China has developed large high-speed printer. How does that compare with technology being developed in the US and Europe? So I'm going to start off on that one. I was actually invited. I went to GIFA and had made some relationships, and I was actually planning on traveling to China. There was actually two printers. Jerry and I had both at GIFA had reviewed the AmSky printer, and then was also invited to Cosel, not only for the fact that they had purchased, I think they purchased two X1 serials, and then more recently had magically developed their own printers, I think, that look very similar. And I think they were also printing, I believe, if not 100%, primarily they were printing with a ceramic media that was being manufactured in China. So that to me, what I saw, I wasn't able to travel there yet due to COVID. But what I saw was that the machines that they supposedly developed were actually very similar to the X1 serial that they had purchased. So I would say that technology was probably closer to being copied rather than developed. So I would say that was probably German technology.
Yeah,
Jared, what's your perception on that?
I don't think there was any doubt that that those were very similar to the exterior units. They made them run when others could not, but that's still older technology. It's still the first generation sand printers. I think we saw from the S15 up to the S-Max, we saw faster speeds, but still with that rastering technology and the recoding technology that really limited and does limit the speed right now. So newer technology, different mechanisms, different ways of doing that are going to increase that speed and bring the cost down. So brings the cost down through simplicity.
Absolutely. So, Rich, I had seen something, I don't have all the details, but I just saw an announcement by X1 that they were going to put a 3D printer in a container ship. Have you read anything on that article yet?
No, Brandon, I have not.
So I found the article interesting because, I mean, I believe, from a DoD perspective, it would actually get manufacturing closer to the point of need. I don't know if, I don't think that it would be binder jetting and actually have a foundry to cast apart, in a forward, theater environment. But what's your perspective? I mean, of having, 3D printed parts at point of need, from a DoD perspective, is that the ultimate goal?
I think our concept of sustainment hasn't changed much. The closer we can get to point of need, the better. If you look at the way the Navy has done things, a lot of you've known about forward casting experts and capabilities, whether it be in Pearl Harbor or in Subic Bay in the Pacific for the PACOM fight. And the ability to manufacture forward is, we have machine trades who use CNC welders and containers on the battle space. And years ago, I'm sure a bunch of you saw the Made in Space folks who put a 3D printer up in space. And then we had a YBI portfolio company here, AST2, who had printers going on Navy ships because the Navy ship has more capability for manufacture, right? And they had to deal with the yaw and turn and what's experienced on a ship. So I think it makes sense. We've seen special operational forces, and we've been part of projects where we've helped to containerize additive manufacturing capabilities. And here's a little whiz bang for all of you. When I left the military academy in '99 to my first real acquisition job, I had to write a requirements document for the training and doctrine command based on a congressional coming out of Michigan for the mobile parts hospital. And the mobile parts hospital concept was something that was in a container forward as DoD moved, a forward-based, here's moving mountains, like when I was in general aid for Schwarzkopf, to just-in-time logistics similar to where industry is. And that mobile parts hospital came to the battlefield in '03 when I was running around trying to do armor. But how we fitted into the concept of logistics, that new technology, had not been worked out yet. So these technology demonstrators, Brandon, are great. And then we have to figure out how does it work in from a concept of sustainment so we could do it. But it's definitely something to follow in terms of the ability to make parts forward as appropriate. So what do we all want? Increased platform availability, increased response time from the supply chain. And that involves a lot of things, like Jerry pointed out, Brandon. We're all moving to that digital thread, right? Where somebody's going to send you a file. And Jerry said something about that printer. I can print you something for that day. Can we finish it that day? And when does somebody have it in their hands? And where do they live? Right? And that's a great discussion.
Well, that's exactly right. I mean, I think By Castings, a company in Ohio years ago, was contracted either by the AFS or the Army, to basically put a foundry in a couple of containers, But at the end of the day, if you don't have all the machining capability and everything else, would you be better off to just have very rapid, centers, like you said, positioned to where you send them the technical data package, they can run simulation, they can design it, they can print it, cast it, and then do all the machining operations. Because just because you have a foundry, out, in a forward location doesn't mean you can do all the post processing. A lot of aluminum parts now are needing hipping and all these other processes that the foundry is one thing, but actually getting that that part or that component ready to bolt onto a tank or a truck or a plane, that's a whole different story. So,
well, I'll bring this up. And we worked on 2 projects with Army Research Labs, and understand research, especially for the military, is looking at technologies that we probably can't do right now. By the way, the Army had containers with portable foundries for years. They had 2 large containers with conventional continuous mixers, molding stations, and a small induction furnace to be able to pour parts at point of use. That was disassembled a couple of years ago. They're thinking about putting 3D sand printing, binder jetting in a container for a much more reduced space requirement container. But I think the current endeavors right now, the current publicity you're seeing on X1, I believe, is all direct metal.
Right.
So they've made some great advancements along with Oak Ridge National Labs and some of the binders, and they're doing expanding their ability to print 3D or binder jet print metal powders. So.
Yep. Very good. Another question we have on here is probably more for Jerry. What is the status of inorganic binder system in the USA? So when we went over to GIFA, a lot of the focus, over in Europe was obviously inorganic. And I know, Jerry, you've dabbled a little bit in that space. So do you have a perception? I mean, now I do know, I think there is a presentation tomorrow. AFS and X1, I think, are going to have an inorganic binder presentation. So I would definitely tell people, to look into that. But I don't know of any other printers in the US that are, I think everybody's doing it pretty much in Europe, but I don't know of any anyone else really pushing the technology. So what's your perspective on the status of the binder in the US? Are we manufacturing it here yet? Or is it all coming over from Germany and Europe? What are your thoughts, Jerry?
All the inorganic binders, I know that ASK is working on inorganic resins. I believe the current X1 technology is based on the Hoopness Albertus. That's all coming out of Germany. The HA International, I do not believe has been licensed yet to produce the materials. When you look at inorganic binders, I think it's the desirability and the need. Is
Right.
someone buying a printer based on IOBs? And the answer is probably no just yet. But we have Lempe that is using IOBs over in Germany. We also have VoxelJet with their production system is using IOBs in Germany. So yes, the technology has been available. It's a little more complicated with the drying steps. As far as I'm aware, it's not a cold curing system. So there is more complexity to the system. One, I think the X1 is just waiting for people to buy the technology.
I agree. I've been approached several times. Hey, why don't you have a phenolic printer yet? Why don't you have a phenolic printer? And I was like, you know what my demand for 3D printed phenolic cores is? Like $5 a month. So why, as a print service provider, we may be one of the largest in the country, but if all the demand is for, most people want a low cost, or at least get close to conventional core making prices for cores and molds. If I only have 1 or 2 people approaching me a month saying, hey, can you try this little spindly pipe core? I'm like, I could print that 1 or 2 cores for you, but you're gonna have to pay for, all the resin, all the binder, to set up and run for 2 cores. Jerry, you and I had this discussion all the time when, we first brought our first couple of jobs, to you and I for printing. I'm like, hey, I finally got a sale. And it's like, I sold it for X and it was going to cost you X times 5 to print that part because, we didn't have enough to fill up the job box at that point. So you're spreading all this material, you're spreading all this, activator on the sand, you're running this $1 million+ asset, to make, $20 in revenue. It just didn't make sense. So
there has been really successful islands of technology for the phenolic resins.
Oh, absolutely.
So I think Danko Arlington has been very successful with their metal operations.
I've heard great things out of Oxyjet. Their service center. And like I said, I don't have anything against the technology. I think it just, circles back to the inorganic. What's the status? I would say the status is there's just a very low demand.
I think when we talk about strength, both room temperature strengths and high temperature strengths, we really didn't see the improvement that was promised with the phenolics. So although we see, say, double the transverse strength at 400 or 600 degrees C, we're going from 6 to 12 psi. It's still not enough. So I think some of the new technologies that we're working on, and we'll see in the next 6 to 8 months, are strengths, high temperature strengths that are not being able to see, that we can't see right now with any of the current technologies. Whether that's IOB or whether that's phenolic resin, those strengths are not high enough for thin cores and either high temperature alloys. So,
yep.
But I think that technology is very a short distance away.
Absolutely. Well, gentlemen, I don't know if you have anything else in closing. We've kind of ran through the questions here, so that means you guys all did let me see if there's any more. Oh, no, there is a couple more. Sorry, I had to page down. How do you vision what we may see at 2022 Metal Casting Congress relating to AM and Foundry 4.0 in Columbus to dramatically different than what we saw in Atlanta?
Oh, I think the technology is changing every 6 months. So the advancements that are being made, I'm talking to companies that are adopting Internet of Things for increased information on their processes. We're looking at really advancements in molding and core techniques. I think we're going to see a lot of new things. So I'm really looking forward to next year when I can shake hands and meet face to face.
And if I might add to that, you guys remember very well, along with guys like Tom Pruka and Jitin Shah and Harold Sears and others, at earlier AFS events, when we were talking about sand printing, we had guys like Jerry and Rick Lucas and a couple of OEMs talk about how they were using sand printing. And then as our presentations in AF events grew, you guys remember we had a standing room only forum once. And now what I hope is that instead of having nonprofits and consultants, we have Jerry and some of the OEMs going on our level, but we mostly have small and medium-sized manufacturers talking about and conversing about how they're using this technology to meet needs and to be globally competitive. And so, well, I think there should be a technology component at that forum in 2022. What I hope to see is that industry has caught up with the technology and we're dialoguing collectively. And before we go out and have some great steaks in Columbus that night and some cold beer, the forums during the day will be about small and medium manufacturers who are leveraging this technology for their benefit and the benefit for all. That's what I hope we see.
Very good. Yeah, I agree. One of the last questions here in the Q&A before we're going to push out to our tables, so everybody stick around. Come and visit myself, Jerry, or Rich. We'll be out there for probably 20 minutes, half hour. If people stick around. But thanks once again, everybody, for joining. The last question here was, what are the biggest challenges of sand 3D printing in terms of quality control, and how do you address them? I can speak to that briefly, and then I'll have Jerry weigh in. But some of the the quality control, it's just really watching your inputs. Make sure that you have good quality sand. The acid levels, and everything is monitored and pretty neutral. And then as well as your binder on these print heads, you're basically pumping a furium binder for orifices that are size smaller than the human hair. So what we want to make sure is that we're getting a good quality consumable from our customers. And then it's basically just making sure that the printers are operating in a very controlled environment. Humidity has a lot to affect. You're basically filling up a recoater full of damp sand, and you're trying to lay those layers very evenly. So if you get a big swing in humidity, the activator level can really wreak havoc on your printers. And like on the one slide Jerry had shown, it looked like the recoater may have plugged up, and the printer just kept printing binder, but the sand wasn't falling out. So come into quite a mess on those mornings. But those are some of the biggest things, because you're the way that you're spreading the sand and pushing the sand. If you get pushing or streaking, those are a lot of the quality defects. I mean, the printers run really, really sound if you have good quality inputs and you keep it in a monitored environment. Jerry, your perspective, you've been on this longer than anyone. So
90% of the quality of the materials we put in that printer. Yep. So the technology is very solid. We have our technology is one of the older units in the U.S. and consistently really requires minimal maintenance and downtime every year. So a big shout out to X1 for a very well engineered and manufactured piece of equipment. But
yeah,
that's not saying I'm not looking forward to new technology.
Right,
faster, cheaper, better. So
yeah, absolutely. Well, gentlemen, can't express enough, how much you guys have done, to help our company, myself, my personal development, in the industry. It's been great, working with you guys for all these years. Glad to see that you're all, successful and, continue to innovate, your businesses. Thank you so much for the time. I know this year has kind of started out pretty hectic, so I know it's hard for everybody to carve out an hour here and there when, all it's going to do is put an hour on the end of your day. So really appreciate, I think we had over 75, registrants. So, this will be, disseminated out to them and hopefully throughout their organization. So, I really appreciate you guys coming on and, and sharing your insights, from technology to, to opportunities, as Rich had mentioned, and challenges, so that we can continue to innovate and continue to go to the next level. So we're going to push out to the tables. Everybody have a safe and happy St. Patty's Day. Thanks for spending some time with us this morning. Hopefully you can stick around and ask any directed questions at the tables, and we'll see you next time. Take care.